looking at the fundamental theorem of calculus, which hopefully sounds like it's important, right? It is, especially on our AP test. So we're in Unit 6 right now. Unit 6 makes up approximately 20%. Just Unit 6 makes up approximately 20%. And we have 8 units, so like they're not distributed super evenly. And like some are like closer to 10%, so like 1 through 4 are all closer to 10%. 5 is like 15 to 18. 7 and 8 are both closer to 10%. So like Unit 6 is the biggest percentage of all of our units. So, and this is probably one of the most important theorems, which is why it's called the fundamental theorem. And so what it's going to allow us to do is to evaluate integrals that are not nice, pretty geometric shape. So remind me, what does an integral give us?
Area under a curve.
Area under a curve. And so especially when we start looking at things that are very curved, right? We can now use this theorem to help us find the actual area. So let big F of x be the antiderivative of little f of x. So then what we can do is if I have the integral from a to b of little f of x dx, what we can do is we're going to take our antiderivative, so we said that that was big F, and we're going to plug in b, or the top bound first, and then subtract off what we get when we plug in the bottom bound. And when we have a definite integral, which remember, so we have bounds, we don't have to put our plus c, because notice if both of these f's are the same, our plus c's would be the same. So if I have this f with a plus c minus this f with a plus c, what happens to our plus c's?
They cancel.
They subtract out to 0, yeah. So that's why we don't have to worry about the plus c's. The other way that we can see this written would be the integral from a to b of v of t dt. So what is the antiderivative, or in other words, I'm going backwards, of v of t? So what do we have to take the derivative of to get velocity? Position, yeah. So instead, this would be s of e minus s of a. So let's look at some examples. Alright, so I have the integral from 1 to 2 of x squared minus 3 dx. So we're first going to kind of just treat it like it is a indefinite integral. So I'm just going to take my antiderivatives. So remind me, like, what is my power rule for antiderivatives?
Plus 1 to the exponent divided by the exponent?
Yeah, so if I have x to the n and I want to take the antiderivative of that, we add 1 to our exponent and then multiply by 1 over that, or we are dividing, right? Either way. Okay, so if I have an x squared, okay, if I add 1 to my exponent, what do I get?
X cubed.
Okay, so then I'm going to have a 1/3 x to the third minus, what's the antiderivative of a constant?
3x.
And we are evaluating from 1 to 2. So 1 is acting as my a value, 2 is acting as my b value. So then we just plug those in. I plug the b value in first. So I have 1/3 2 cubed minus 3 times 2 minus, and you can do this one of two ways. I like to just put parentheses around my entire second part. So notice that I have a 1/3 times 1 to the third minus 3 times 1. Okay. Or you can also distribute it. The thing to be careful about distributing it is that I do have to distribute this to the second term as well. And a lot of people forget that if you don't put the parentheses. Which is why I think it's helpful to go ahead and put the parentheses. Now, if this was a free response question, once I have plugged in my bounds, we can stop there. Because from there, it's just numbers. Yeah? And so we're okay with that. However, if it's a multiple choice question, they are going to simplify that. So 2 cubed gives us 8. So I have 8/3 minus 6 minus 1/3 plus 3. So 8/3 minus 1/3 gives us 7/3. And then -6 plus 3 gives us and then our common denominator would be 3. So I would have 7/3 minus 9/3, which is going to give us -2/3. So what did we say that an integral represents?
The area under her.
Okay, so what does it mean for it to be negative?
For it to be under the x-axis.
Okay, does that mean all of it has to be under the x-axis? Not necessarily. It just means that more of it is under the x-axis than above. So what does our graph of x squared minus 3 look like?
A u.
It's a u, so it's a parabola. Specifically, what's happened to our parabola?
It's been shifted down by 3.
And we are going from 1 to 2. This is 3, 3, 1 point stuff, so it's going to be a little bit past, right? So it's going to look something like that. That's not exact, but you know, we get the rough idea. So notice that my area here would be negative, and my area here would be positive. But we have more negative area, which is why we end up with a negative answer. And the way that you can kind of think about it is like our velocity function, right? The velocity, when we get a negative, it doesn't represent like negative distance or something like that. It just represents the direction. Same thing here, area is a measurement, so the area itself is not technically negative, it's just telling us a direction, as in below the x-axis. Alright, questions on that one? Yes? No? Okay? Alright. So this time I have the integral from -2 to -1 of u minus 1 over u du. I have a different variable. Is that okay? Yeah.
Yes.
What is the antiderivative of u? So what's my exponent thing?
1.
1. So if I add 1, I get
It's 2.
2. But then we also have to
1 by 2.
divide by 2, or 1/2. Okay. Then remember that sometimes we have to rewrite things in order to take our antiderivative. So like if I have 1 divided by u squared, I can rewrite that as u to the -2. So if I have the antiderivative of that, I'm going to add 1, which is -1, divided by -1, so I just get -1 over u. However, here, what is 1 over u? What would I write that as?
U to the -2.
Okay, so what happens when I add 1?
U to the 0.
Does that make sense?
No.
No. Do you remember what the antiderivative of 1 over u is?
Natural law.
Yeah, it's our natural log. So again, we're going backwards, so we can kind of think about the derivative of what gives us 1 over u or x, right? And it's going to be the natural log. But we do have to be careful, because since we're going backwards, what are we not allowed to have inside a natural log? Negative. So it's actually the natural log of the absolute value of u. So I have minus the natural log of the absolute value of u. Oh, and I don't think I specified, so this bracket that I have here just means that I am evaluating. So, like I said, we treat it as just a normal antiderivative first, but then we have to plug in our bounds. And so this basically tells us, like, okay, I've taken the antiderivative, so I need to drop my integral once I've taken the antiderivative. But if I haven't put my bounds in yet, I can't just not have bounds on it, so this means to evaluate. Sometimes you will also see, like if it was, whatever this is, 1/2 squared minus the natural log of the absolute value of u, you'll see just like a big line. That also means to evaluate. I tend to not like that notation because some of y'all's handwriting isn't great. And y'all's evaluating symbol ends up looking like a big 1 or another absolute value sign or a parentheses or like weird stuff. Versus if you go ahead and do like the full hard bracket, it's a little bit harder to mess that up. Are we all with me? So that's why I tend to use this one instead. But
why are you looking at me?
So which one am I going to plug in first? -1. So -1 squared gives us 1. So times 1/2 is just 1/2. And this is where our absolute values are going to be particularly important because we can only take the absolute or the natural log of positive things. So I need the absolute value there. So I get the natural log of 1. Then I'm subtracting and we're plugging in. What's our bottom bound? -2. Okay? So -2 squared gives us 4 minus the natural log, well the absolute value of -2 is just 2. What is the natural log of 1? 0, right? Because remember, natural log undoes exponents. So we're saying e, because that's my base for a natural log, e to what power is 1? Well, the only thing or power that I could raise e to get 1 is going to be 0. So that's going to go to 0. So then 1/2 times 4 gives us 2. And then I have a negative, so I can go ahead and apply that to be positive. So then 1/2 minus 2 is going to give us a -3/2. That's a bad 3/2. 3/2. There we go. Plus, the natural log of 2 is not going to be a very nice, pretty number, so we'll go ahead and leave it like that. If it was a calculator active, you might see it as a decimal approximation instead. How many decimals do we round to if we're going to approximate? 3. Okay. Don't get taken off because you just don't write the last decimal. Now, at what step could I have stopped if that was a free response question? Which would be step 2? Yeah, so we could have stopped at that line. What question is we have there? Okay. Next one. Says find the area of the region bounded by the graph of y equals 1 over x, the x-axis, and the vertical lines x equals 1 and x equals e. So remember that you will never be graded on a graph, like on how well you can graph something. However, being able to graph stuff is really important for some problems, which we've looked at some But especially here in like this section, when we've done all of our Riemann sum stuff, right? And then when we're looking at area under a graph, it's helpful to know what that graph looks like. And then when we get to unit 8, it's also going to be really important that we have a basic idea of our general parent graphs. So what does the graph of 1 over x look like?
C.
Just one?
Like C. I don't know how to describe it. It's like going down and it's going up.
So I'm assuming kind of like an L shape
Yeah.
that way. But then I also have one going the opposite direction. So remember that the denominator is not allowed to equal 0, which is why we have a vertical asymptote at 0. And because it can't be 0, that also means that our y value doesn't end up being 0, so that's why we have a horizontal asymptote as well. Now, what are our bounds this time?
X equals 1 and X equals E.
Cool, what is E?
3 something.
That would be pi.
1 plus something.
2.7 stuff, yes, or over here. Which is helpful because could I have gone from 0 to 1? Why not?
Because there's the infinite.
Because it would be infinite. Okay, it's what we call an unbounded integral, which is on the BC test, but not on the AB test. So we have to have things that are continuous. And at 0, we have a discontinuity. So the area that we're looking for is this little shape right here. So I want you to set up and evaluate the integral that represents that area and tell me what you get. So once you get an answer, turn and check with the neighbor. It should be a nice, pretty answer this time. So remember, we don't use this. Because when I have bounds, I don't have the double C. Because notice here, I would do C minus C. So my C's end up going away. So we just don't put it.
Yeah.
What do we get?
1.
You should get 1. So I have the integral from 1 to e of the natural log of x dx. Not dx, sorry, 1 over x. I end up getting the natural log of x. I was ahead of myself there. So I get the natural log of x from 1 to e. This time our absolute values aren't as important because my e and 1 are already positive. We said a minute ago, what is the natural log of 1? 0. And again, this is basically saying e to what power is e? Well, e to the first power is e. And so that's our answer. antiderivative rules. Next week my goal is to give y'all like a little handout or foldable that has all of your antiderivative rules on it. You can also look at your derivative rules, right, and just go backwards. So you technically already have them, but. Alright, the next other thing that we have, so we have FTC and then we also have MVT. Lots of acronyms today. What is a mean value? Besides like not nice.
It's an average value.
Average. Okay, so we're talking about an average value here. So in calculus, when they ask you for an average value of a function, they are asking you for an integral. They are not asking you to add two things and divide by 2. Are we all with me? So we want the calculus average value. But first let's look at like what that means. So if I have a graph, it does, doesn't really matter. Looks something like that. Yes, no, maybe. And I want it to go from A to B. We're okay with that. So then, what does our integral represent? Area under the curve. So all of that stuff. Agreed? Okay. This would be our f of b value. Down here is our f of a value. Now, that's a very curvy shape, right? We don't like curvy shapes because it ends up we have to do a little bit more math with it. We like nice, pretty geometric shapes. So what our mean value tells us is that somewhere along this, where would it be here? Ish, here. There's going to be some c value. We don't know what c is. It's going to be different pertaining to each individual function. But what happens then is basically that f of c value is the average value. So what ends up happening is that this like leftover space, mine's not super accurate, this leftover space is the same as the space that was above it. So this rectangle, which is now a nice pretty geometric shape, is the same area as what my original green graph was. So my green graph was the integral from a to b of f of x dx. What would be the area of my rectangle E shape? So what's my height?
F of C.
F of C. Okay. What's our width?
F of A plus F of B.
Not quite, because those would be heights.
A plus B.
What?
A plus B?
Not quite.
Right.
How do we find distances between two things? We don't add them, we subtract them.
B
So it would
minus
be B minus A. Yes? No? Now, be careful, and I tried to kind of put it more to the right just for that reason, that C is not necessarily halfway in between, okay? It has to be in that interval, right? But it is hardly ever, like, exactly halfway in between. And because a lot of people want the C to be, like, they want that B minus A to just be 2C instead, and it's not. So, like I said, this is this nice pretty C value that allows us to create this rectangle. What this also can give us is, if we solve for this f of C, this f of C is what we can then label the average value of our integral. So notice that if I wanted to solve for f of C, I would divide my b minus a over. So we're just going to write it as a fraction. And that is our average value. So when you're asked to find the average value of a function, they're asking you to find this integral. a lot of times it'll be an application type question. And we'll look at one like that in a second. Questions so far on that? Does that kind of make sense? Hopefully a little. Okay, so let's look at an example. This says find the average value of the following function on 1 to 4. Now be careful, because when it says average value, a lot of us want to go like algebra 1 average value, right? I want to plug in 4 and I want to plug in 1, add them together and divide by 2. But remember, this is calculus average value, so we need an integral. So we're going to label it as f of c equals. I'm going to write out the full formula just so that we have it for reference. What are our a and b this time? What's my integral? 1 to 4. So I have 4 minus 1 times the integral from 1 to 4 of my function. So 3x squared minus 2x dx. And really, as long as you remember your formula, average values are pretty straightforward, because the only thing that's different about this than any of our other problems is that I have a fraction in the front. But you can mostly leave that just like factored out and just apply it at the end. So what is the antiderivative of 3x squared?
X cubed.
Because I would add 1 and then divide by 3, but I already have a 3, so it's 1. What's the antiderivative of negative 2x?
Negative x squared.
And we are evaluating from 1 to 4. What is 4 cubed?
64.
Okay. What is 4 squared?
16.
Okay. Then I'm subtracting. Well, what is 1 cubed?
1.
What is 1 squared?
1.
So what do I get in my second part?
0.
Yep, that part just goes to 0. What is 64 minus 16?
28.
Yep. Times 1/3.
16.
So that is the answer. Like I said, the biggest part here is just remembering to have that 1/3 in the front. What questions do we have on that one? Now that was our average value, right? What's this f of c? Sometimes they can ask us to take it a step further, and they can ask us to find the c guaranteed by MVT for the interval negative pi over 3 to pi over 3 of f of x equals cosine of x. So my setup is going to be very similar. Okay, so we're going to find our average value first. So f of c. What's my b value? What's my b value? Pi over 3. And we are subtracting a negative, which is the same thing as adding. So I get pi over 3. Yes? Times the integral from negative pi over 3 to pi over 3 of cosine of x dx. So, what is pi over 3 plus pi over 3? Now, what is the antiderivative of cosine? So the derivative of what is cosine? positive sign. Yes, are we okay with that? The antiderivative of sine is a negative cosine. So I have sine of x evaluated from negative 5/3, 5/3. Are we all okay with that this is also equal to 3/2 pi? Just to write it a little bit nicely. And then what are we gonna plug in first?
Negative 5/3. 5/3.
We plug in our b value first. Yes, so maybe. What is sine of 5/3?
Square root of 3/2.
Now, which quadrant is negative 5/3 in?
4.
Okay, which means that I will also get a square root of 3/2, but sine is going to be what?
Negative.
So I get a negative negative, which is,
Positive.
okay. So if I have square root of 3/2 plus square root of 3/2, what is that also?
2 square root 3/2, which is just square root of 3.
Correct. And then I'm multiplying, so I end up with 3 square roots of 3/2 pi. Is that going to be a very pretty number? No. So we're just going to leave it like that. But that's my f of c. Yes? It asks us specifically just for c this time. So this is a y value. It's asking me for the x value. So I'm going to take my f of c and set it equal to my original function. How do I undo a cosine? That's the reciprocal.
Oh, arc cosine?
Cosine inverse. So if it asks for an exact value, that would be our answer. If it asks for or gave you a decimal, you could just plug into your calculator. But because I have pi's over 3's, what mode should I be in?
Radius.
Yes. And what do we get? Anyone type into a calculator? No? Okay. You get 0.597. You ready for one last one? This one looks fun, doesn't it? So, guesses are, do we think this is calculator active or non-calculator active?
Non-calculator active.
Looking at the decimals that I have there, do we think this one's calculator active? You are not expected to know what that graph looks like, especially if I have a t cubed in there. It's not going to be a very fun graph. So it says the volume V in liters of air in the lungs during a 5-second respiratory cycle is approximated by the model V equals 0.1729 T plus 0.1522 T squared minus 0.0374 T cubed, where T is the time in seconds. Approximate the average volume of the air in the lungs during one cycle. That's a lot. is average value for us? The integral, right? Okay. Now, we do have to read a little bit because it says that what is one cycle?
5 seconds.
5 seconds, right? So I'm going from t equals 0 to t equals 5. So I would have 1 divided by 5 minus 0 of the integral of v of t dt, and we're going from 0 to 5. Yes? Now, if this is calculator active, okay, you're going to get probably 2 points for this part. Okay, you're going to get 1 point for a setup. Basically, do you know that an average value is an integral? And then you're going to get 1 point for your final answer. If I'm not getting any points for my work, should I show my work or should I let the calculator do it for me? I should let my calculator do it for me. So, just like your calculator can evaluate derivatives at specific numbers, we can also evaluate integrals at specific numbers. So, the first thing I'm going to do is let my f of x equal all of this jazz. Now, it does not like t's, so you're going to have to use x's. So I have my function, yes? Why are you mad? Oh, too many equal signs. There we go. And I have my nice pretty function there, yes? We said that I am looking for the integral. So what's nice is for Desmos, you just have to type in int, and it gives you an integral. I'm going from 0 to 5 of f of x. Now, notice that it's still giving me an error, and that's because it gives you a hint, right? I have to have my dx. Okay, but what am I missing right now? Yep, and I can just put that out on the front. Now, if it's like if it's a multiple choice question, you can go ahead and convert this to fractions. If it gave it to you as fractions, it's not going to give you that one as a fraction. But if it was a nicer fraction, you can use that fraction button for it to give you nice fractions. But in this case, we get 0.532. And we are in liters, yes? Yes? No? Maybe? Liters what?
Liters per second.
Not per second. This is just the average value, which is not going to be a derivative. It's not the per time, but a volume is a what type of measurement? It's a cubic measurement, so it would be meters cubed. And that would be our answer.